Myself Praveen, I am your physics teacher. In today's class, we are going to discuss about dual nature of light. In dual nature of light, we are going to discuss the topic photoelectric. Without wasting our time, let's move on to the topic. Dual nature of light. We all know that light has particle nature as well as wave nature. In experiments or phenomena like reflection, we know that light will act as particle. In experiment like interference, diffraction, we know that light will act as wave. In photoelectric effect, in a single experiment, we may see that light will act as wave as well as particle in a single experiment. Okay. Now we are going to see that. Okay. We all know that light carries energy. All electromagnetic waves carries energy, right? We know that. What is this energy proportional to? If an electromagnetic wave have different wavelengths, which this proportional to? Okay. So the energy is proportional to frequency of the wave. Okay. If a light has more frequency, it has more energy. If light has less frequency or wave has less frequency, it has less energy. Okay. This frequency is inversely proportional to wavelength of the light. Okay. So frequency and light wavelength will be related like this. Okay. Frequency of the wave will be c by lambda. Okay. What is c? C is speed of light. What is lambda? Lambda is wavelength of a particular light. Okay. So if a light has more wavelength, it has less energy because E, from this we know that E equal to hc by lambda. Okay. So if a light has more larger wavelength, it has less energy. If light has lesser wavelength, it has larger energy. We all know that gamma rays have less wavelength. Okay, so that they hold highest energy in electromagnetic spectrum. In radio waves, we know that radio waves have larger wavelength. Okay, so they carry less energy. Okay, like this, light will carry energy. Okay, which one carries this energy? Light will act as wave packets. Okay, these wave packets has frequency as well as the particle nature. Okay, we will see in next slides that how these wave packets will eject electrons from the surface. Okay. Now I am going to say this slide. The photoelectric effect is nothing but when we expose a metal to photons, these photons will eject some electrons, free electrons from the metal surface. Okay. So not every photon can do that. Okay. If light have highest energy or higher energy, so that they can eject photoelectrons from this metal surface. Okay. What are photoelectrons? When photon hits the metal surface, if the electrons ejected, these electrons are called photoelectrons. Okay. What kind of electromagnetic radiation can cause this or produce photoelectrons? Okay, we will see that. If every metal has binding energy with its electron, right? We all know that. If the electron have binding energy, how it can be ejected? By this metal bombarded by the energy more than the binding energy. Okay, if a photons have higher energy, like the photon have energy like h nu, if it's more than its binding energy, like this energy, these photons can produce photoelectric effect. It means if a photon have enough energy, if strikes in metal, it will eject electrons from this metal surface. Okay. What is this binding energy? This binding energy which binds the electron in the metal surface. Okay. If we have enough energy to break this binding energy, we will remove electrons from the surface. Okay. So for now, just look at this equation. This is photoelectric effect equation. If this E is supplied energy or energy of a given photon, the energy of a photon will be separated into two parts. If the photons have energy more than binding energy, it will produce ejection of photon, right? So it will lose some energy. So the photon will give energy to break the bond or binding energy between electron and metal plates. So it will break the bond. Okay. So after breaking the bond, the balance energy of electron will converted into kinetic energy of those photoelectrons. Okay. For instance, if the energy equal to phi, then there are no kinetic energy for electron, right? If the energy only equal to the minimum energy or binding energy of the metal, so binding energy of the electron to the metal, so there are no kinetic energy for electron after the photon strikes on metal surface. Okay, if the photon carries more energy, then these electron will move with kinetic energy. Okay, the minimum this energy this phi is also known as minimum energy to produce photoelectric, right? Which is also known as threshold energy. Okay, if a light carries h nu, if the function or this threshold energy is h nu dash, okay, this minimum frequency which produces photoelectric effect is also known as threshold frequency of the metal surface. Okay, this is the minimum frequency to produce photoelectric effect. Okay, this function or this phi threshold energy is also known as work function. We need to do that work to produce photoelectric effect or to remove electron from the surface, so they called as work function. Okay, this work function can be written in terms of h nu dash. Okay, they are all energies, so they hold same units. Okay, energy as units joules, right? So h nu we can measure it in joules, because we can also measure it in joules. Kinetic energy is also energy, we can measure it in joules. Okay, so the dimensions are correct. Now we know that h nu equal to h nu dash. This h nu dash is the minimum energy to produce photoelectric effect. Then the balance energy will transfer into kinetic energy of the electron. Okay, what is the formula for kinetic energy? You know that it's half mv square. We are going to see kinetic energy for electron, so I'm write suffix m suffix c. So mass of electron, velocity of mass of electron multiplied by square of velocity of electron. Okay, this is photoelectric effects equation. Photoelectric effects equation. Okay. Now this is the experiment we are going to see. Okay. If lights the same setup, but we are just turn the plate like this. Okay. If light falls on this, the metal surface will eject the electron, so that the electrons will be captured into electron. Okay, let's first solve the construction of electron. We are producing high potential in this tube. Okay, it's a vacuum chamber, so that there are no disturbance. It's like an isolated system. Okay, it's a metal surface. It's a ammeter which reads current. It's a battery. We are going to produce a potential difference between these two plates, so that's a battery for it. Okay, when light hits metal surface, it will eject electrons, right? It will eject electrons if light have enough energy. Okay, now let us assume that light have enough energy, so it will eject electrons from the metal surface. When light hits metal surface, it will eject electrons. These electrons will be collected into the detector. Then through detector, the electron will flow through the circuit, so the ammeter can measure the current reading. Okay, we all know that current is charge per time.